Good morning, Year 3. Welcome back to Science. Today is our second lesson in our new unit of light, and we are going to be looking at how light is reflected off of surfaces and off of objects and into our eyes. So I'm just going to share my screen now so that we can get on with today's slides. Okay, so in this lesson, we are going to be identifying how light is reflected. By the end of this lesson, we will know that light travels in straight lines from a light source to an object or from a light source into our eyes. We will also know that light reflects off of an object and into our eyes. And we should also be able to describe which objects and materials reflect the most light and then design our own reflective jacket that will best reflect light. So let's get started. First thing we're going to do is a quick recap quiz. What you need to do is I'm going to read the question out to you. You are going to pause the video after I've read the question, shout out your answer, and then you can play the video again to check if you got the correct answer. Are you ready? Are you ready? Okay, here we go. Question number 1. An object which emits light is called A. Is it source? So light source. B, is it mirror? Or C, a light reflector? Pause the video now so that you can answer this question. Okay, the correct answer was A. An object which emits light is called a source. Question number 2. Most light sources also emit A. Power, B. Heat, or C. Noise. Pause the video now so that you can answer that question. Okay, most sources of light also emit heat. We looked at this last week and we were able to identify that most sources of light, like the sun, lightning, fire, even light bulbs, emit heat as well as light, but not all of them do. Especially bioluminescent animals, they don't tend to emit heat. So the jellyfish, the glowworm, they wouldn't be hot or warm if you touched them. Question number 3. Light travels A. at the same speed as a rocket, B. at the same speed as Usain Bolt, who is the fastest man in the world, or C. faster than anything in the universe. Pause the video now to answer that question. Okay, light travels faster than anything in the universe. It is the fastest traveling form of energy. Light is faster than the speed of sound. Question number 4. These light sources have been divided into 2 categories. Over here in category A, I can see there's a bioluminescent jellyfish, there's the sun, and there's lightning. In B, I can see a torch from a phone, I can see a lamp, and I can see some glow sticks. What I need you to do is I need you to identify the categories. What would you call category A? What type of sources are they? What type of sources are category B? Pause the video now so that you can answer that question. Okay, if you worked it out correctly, you should have been able to identify that category A were natural light sources. So I'm going to put natural light sources. And category B were man-made. I should be doing a hyphen in there. Man-made light sources. You can also say artificial light sources. Okay. Fantastic. Moving on, let's go through our key vocabulary today. So these are some of the words that are going to be featured in this lesson. I'm going to say them and I want you to repeat them after me. Light source. Light source. Your turn. Fantastic. A light source is an object that emits light. That means it gives out light. Our next word is going to be light rays. Light rays. So light travels in straight lines, and these straight lines are called rays. Rays of light or light rays. The next word is reflect. Reflect. So how we're able to see things is because light reflects off objects. So reflect simply means when light bounces off an object. You can see in this picture here, there is a torch that's being shone on a surface, and the light rays are reflecting off of the surface and into the person's eye. Which brings me on to my last word, eyes. Eyes. Great. Okay, so just a quick recap on what is light. Light is a form of energy that enables us to see all the things around us. Light travels faster than anything in the universe. It is so fast you couldn't even time it. You wouldn't be able to time it, it's that fast. Now I've got some missing words here. Hopefully you can help me fill this out. Any object that gives out light, what's that word that we use that means to give out light? Well done, emits. Any object that emits light is called a, what was one of our key words from vocabulary that means a something that emits light? We would call it a light. Hopefully you got that right, a light source or source of light. First thing I want you to do, if you can, if you've got a bathroom or if you have a mirror, if your parents have a mirror, what I need you to do is go and look in the mirror and look at your eyes and have a look carefully. What can you see? Pause the video so that you can do that now. Okay, hopefully you've come back, you've had a good look at your eyes in the mirror. I know it can be quite weird to stare at yourself, but it's good to see what exactly our eyes are made up of, the different features of our eyes. So as you can see, we have our eyelids and we have our eyelashes, but if you look a little bit closer, you have the pupil, which is the black center in your eye. You also have the iris, which is the colored area around it. That pupil in your eye is what light is reflected into, and that's what you see. That's how you see light and other objects. So you're probably wondering, how do we see light? And you're probably thinking, well, that's easy. We see light because we just look at the light. And you're right, we do. When light passes through air, the light rays travel from a source into a straight line into our pupil. So as you can see here, we have a light bulb. This man is looking into the light bulb. And these light rays, which are my arrows here, are traveling in a straight line from the source into his eyeball. But we also see objects because light is reflected off of them. Remember, reflect is one of our key words, which means to bounce off of. The light rays travel from a source, so in this case, the source is the sun, and it travels in a straight line and hits an object. Once it hits the object, and in this case, the object is the apple, so the light source, the sun, has hit the apple, the light rays now are going to travel in a different direction. And that direction is going to be to our eyes. So these light rays are being reflected from the sun onto the object, and the object is reflecting those same light rays into our eyes, and in particular our pupils. And that's how we are able to see. What I'm going to do is I'm just going to show you a video now that just depicts exactly how we see objects. So let me stop sharing my screen and share it again, and we can watch this video.
Have you ever wondered how your eyes work? What's really happening when you see something? Of course, you can only see something when there's light. And what is light? It's energy that zooms around very quickly. Light bounces or reflects off most objects, but not everything. When light hits your eye, it actually goes right into it through the opening at the front. The eye then sends signals to the brain. That's what we call seeing.
Fantastic. Okay, what I want you to do now is just pause for a second and think, what did I learn from that video? And if you want to watch it again, I will put the link in the home learning science box. So we're just going to go back to our lesson. That video just showed you how light is emitted from a source, hits an object, and then bounces into our eyes. The only way I'm able to see anything is because light is hitting that object, and then that object is reflecting those same light rays into my eye. So if you look around now, wherever you are at home, if you look around at any object, the only way you're able to see that is because light is reflecting off of that object and into your eyes. This brings me to your first task. Your first task is for this picture here, which you can access on the links, I would like you to draw arrows on this diagram to show how the light is reflected. Where does the light travel from, the source, and how does this person see the rose? So you need to draw arrows to show me how this man sees this rose. Think about where the light starts from, what it hits, and then that object it hits is going to reflect the light into the eyes, and that's how the person is going to see. Okay, once you've done that, you might want to pause this video so you can do that activity, and then you can listen to the instructions for the second part. On the other half of the sheet, you have an illustration, and this illustration has some sentences that have been split up. They've been divided. If you put them all together, it forms a sequence to show how the man sees the rose. What I need you to do is I need you to number these events, these sequenced events. Okay, I need you to number them and put them in chronological order from where it starts. So from when the source is emitting light to the person actually seeing the light. Put them in order by numbering them 1, 2, 3, and 4. Okay, can you pause this video now so that you can do that activity? Okay, I'm just going to make this a little bit bigger. Right, hopefully now you've done the activity, and now we're just going to number them. So for the arrows, if I do the arrow should have started coming from the sun. There should be straight lines, and it should hit the rose. Once it's hit the rose is then going to reflect the light into the man's eye, and that is how he sees. Hopefully your drawing at home looks exactly like my one here. Now we're going to number these events and put them into the correct order. So, first things first, the light travels in straight lines from the source to the object. That should be the first event. That was number 1. Once the light hits the rose, it is reflected off in the opposite direction. That's number 2. So first you can see that the sun has emitted light, which has hit the rose. Now the rose is reflecting the light into a different direction. The light reflects off the rose and into the eye. That is number 3. So now the rays that are being reflected are actually hitting the eye. And finally, number 4, the rose can be seen. I hope you got that correct at home. Don't worry if you don't, because we are going to be going over this again. So, when you think about all the different objects and materials that reflect light, some materials and objects are more reflective than others. Can you think of any materials or objects that reflect light better than other materials and objects? Pause this video now and have a think. Okay, hopefully you've had a good think at home. Maybe you've even been able to collect some objects and materials that are reflective of light. I'm just going to show you a few in case you weren't able to identify any. Here are some ideas. Look at these different objects. What do they have in common? Look at this reflective strip. Here we have a mirror. It's very shiny. Again, the kettle is very shiny, and we've got a handle that says metallic. We have some glasses that are very reflective. We have some metallic objects. We also have a white shirt. So, shiny metallic surfaces such as metal reflect light a lot better than dull surfaces such as cloths or rocks. Okay, and I'm going to show you an example of this. Let me stop sharing my video. Okay. So I have a light source here. I have a torch. This is my phone light and is a torch. I have a mirror as well. This mirror you can see is reflecting the light, and if I hold that to my face, you can see it's reflecting the light, and that light is hitting my face. This is because this mirror is a reflective surface. Now, if I try that same thing, if I try to shine my torchlight onto the paper, you can see the paper is absorbing a lot of the light. Not a lot of the light is being reflected off of that. And again, if I was to hold the torch, you can see I'm holding the torch, it's still on, and I'm going to hold the paper in front of it so that it should reflect into my face. You cannot see that same reflection that you could using the mirror. This is because this paper is a dull surface. Okay, it's not very good at reflecting light, whereas the mirror is a shiny surface and it is good at reflecting light, and you can see that light is being reflected on my face. There you go, you can see that's being reflected on my face. Let me reshare my screen again, and we can go back to our lesson. If you have a torch, your parents' torch from their phone, or if you actually have a torch or any light surfaces, any light sources, can you please try to reflect some light onto a surface, onto a shiny surface or onto a dull surface, and see the difference between those. Pause the video so that you can do that now. Okay, hopefully you've had a chance to do that. My next question to you, have a look at these people here. You may recognize somebody, looks a bit familiar, this person here. These people are all wearing reflective clothing. Here you can see a reflective jacket that Miss Williams is wearing. Yes, it is I. And you can see this reflective jacket in action. Some light is shining on this reflective jacket, and it's reflecting that light. We have a lollipop lady, and they're there to help you cross the road. And you can see she's wearing a reflective jacket, which has some retro reflectors on that, same as the cyclists here that are cycling in the dark. My question to you at home is, why are these people wearing reflective clothing? Pause the video now so that you can identify why. Hopefully you've had a chance to do that. I'm just going to explain a bit better. Reflective clothing helps to keep you more visible in the dark when a light source is present, such as car headlights. Different colours reflect different amounts of light. Certain colours and materials are chosen to be more reflective in the dark. Retroreflectors, which is this material here, and is what my whole coat is made out of, are used in road signs and in outfits that people wear in the dark to reflect light along the path from which it originates, making it seem a lot brighter. What I'm going to do now is I'm just going to stop sharing and reshare you so I can show you this video, which just informs you a little bit better about how light is reflected.
If you're going to be out in the dark, it's a really good idea to wear clothes that reflect light well, so you can be seen easily. Different colours reflect different amounts of light, and the material a piece of clothing is made from may affect how light is reflected. The yellow jacket seems much brighter than the dark red one. You can see it more clearly because it reflects more light. But some materials can behave surprisingly. This grey jacket doesn't seem to reflect very much light. Even with the headlamp shining, it doesn't look very bright seen from this angle. But seen from a driver's point of view, the bands show up really well. That's because these bands are made out of a special material which reflects light in a particular way. Light from the headlights is scattered in all directions by the yellow jacket. But when the light from the headlamps reflects off the bands, it all reflects back down the same path, straight to the driver's eyes. Because more reflected light reaches the driver's eyes, it looks much brighter. The material the bands are made from is called retroreflective. The light from the car headlamps falls on a road sign, but from the roadside the effect isn't very special. But look at the view from inside the car. The signs look really bright. Nearly all the light from the car headlamps is reflected back off the sign to the driver's eyes. That's because the signs are made from retroreflective material too. But even the best reflective gear doesn't work if there's no light source at all.
Okay, again, hopefully you picked up something from that video and how important it is for people who are in the dark to be wearing retroreflective material. So just to go back to our slides, now I'm just going to explain your independent task. Right, unfortunately, something very bad has happened to me. Miss Williams has lost her reflective jacket, which I needed for my camping trip coming up. Can you design me another reflective jacket using a different material? What I would like you to do is I would like you to explore your house for appropriate materials, or if you haven't got any reflective materials at home, choose a material from above. So one of these four materials: foil, wool, towel, or white cloth. Okay? Remember, I need my jacket to be as reflective as possible because I will be wearing it at nighttime. So what your activity is going to be to do, you are going to design a reflective jacket. You're going to label what material you're going to make it out of, and you're just going to write a sentence or two explaining why you've chosen that material to make the jacket out of, why it's appropriate. Some questions and points you might want to consider is what material have you chosen? How was it suitable? And describe how it is reflective. I would like you to label how that jacket is going to reflect light into my eyes. Some words you might want to use, keywords, shiny, metallic, reflective, and bright. I'm really looking forward to seeing lots of your jackets, and maybe I can choose the best one. Okay, fantastic. Well done. I'm looking forward to seeing your work. Make sure you upload it onto CSER so your teachers can see. Bye.